correlation studies. Up to correlation studies. Any last week? On correlation, any questions so far? Maybe you check and you have something you want to ask about it before we move on. Today, I want to introduce us to SPSS. So hopefully by Thursday, we can use the SPSS package to do some analysis, especially regression. We can also do some other tests that we need to do, we mentioned in our studies. So we use the SPSS to demonstrate how it is being done. I don't know how many of you have SPSS package on your laptops.
We don't have one.
Okay. I will use my screen to demonstrate how to key data into SPSS and the procedure for different analysis. But theoretically, today, you have uploaded the slide. We will go through it scantily to see key things so you can fall back on when you have the SPSS to know how to do. Then we'll demonstrate the use on Thursday during our tutorial. So I will have put up a question or a set of data that we will use to run different analysis. Is that okay?
Okay, Doctor.
Yeah.
Doctor,
Yes.
we need to learn the chi-square.
Chi-square, we can use, well, it's just I gave you the formula over there, but I don't think you will need to calculate it under any exam condition. But it's better, we can use even the package to do the analysis when the chi-square is needed. But if we need to demonstrate the table I gave to you there to analyze to find the chi-square value, we can do it in the tutorial also, so that we'll be able to cover what we need to cover with SPSS today. But it's just a demonstration. Most of the time you use system when you do analysis that involve chi-square, the system will generate the chi-square for you. You just pick your reading. Okay. Is that okay?
Okay.
Thank you. Yeah. Let me try and share I will share my desktop so that I can move from one screen to the other, one apps to the other. Desktop, okay. I guess you can see my screen now.
Yes.
Okay. So today we are going to look at the data analysis using SPSS. SPSS is common for questionnaire survey analysis. It can do some numeric analysis too, but not much of econometry. We can use it to do regression, correlation, and various tests for statistics, both descriptive and inferential. So this will be the learning outcome of the usage of SPSS. So what are the uses of SPSS? It's good in data entry and data cleaning, can do descriptive statistics analysis and give outputs, do parametric and non-parametric tests, test of relationship and differences. Data division based on factors and groups. If you have key in some data and you want to divide it into male, female respondents, it can be done. So we can do codes and themes, market research and trend, data management, predictive analysis, which is regression, and data mining. So the SPSS has the capability for all this. So it's one of the most powerful data analysis software. However, there are other data analysis software that I use, especially mathematical, statistical, R+, eViews, and Strata. All these are equally good. Statistical is statistics software, just like SPSS, same thing like Strata. eView is for econometrics, which is more of time series regression. So when you launch when you're to launch to SPSS, just normal way of launching into apps. You launch into SPSS. Then and if SPSS, if you are there, this is the kind of prompt you will see. Though this may vary, the way it will display may vary from version to version, but this is a typical view of a launched SPSS prompt. And these are called cells. The title bar, the minimum, maximum, we can all see this in screen because we have been using different software. So which is more important to us is the view. So we can see the cell just as in Excel.
Sir, we can see the cell. Oh yeah, all right.
Yeah, so that's a cell. So as I remember what I call a case. So any entry you enter on this line form each cases. So by the time you enter your full data, when you so menu bar, these tools, these are what we look at for analysis. If you want to see data screening, data transformation, analysis, so we pick from there. Graphs, if you want to bring out graphs. So these are views. The views, you can see the data view, you can see the variable view. Data view is when you have put your data inside. And variable view is when you are defining your variable. So the much important thing in SPSS is to define the variables. So we'll have to define variables. So when you have defined your variable, then you can come and see them in data view. So an output where when any analysis is done, this is how the SPSS will bring out the output result. So whatever analysis is done will be listed in this plane. So this pane shows you all the tables, whether significant or not, while this one gives a list, a kind of outline of what analyses are displayed. If you do more than 4 different analyses at a go, the table pane will display the outputs, while the pane will list each analysis that has been done, whose output has been listed. And the saving format of SPSS is .spf. Whatever name you give to your file, .spf. So data entry. There are ways of putting in data entry into the SPSS. So a variable name can be as long as 256 characters long. Must start with a letter. Spaces are not allowed in variable name, so you don't create space when you are giving the variable name. So let me, as I'm explaining this, let's go to SPSS Screen. So this is the first thing in SPSS. variable view. I think you can see it very well. So if you want to key in a data, supposing you have collected the data about maybe a survey data that has to do with height, it has to do with age, it has to do with weight, it has to do with scores, it has to do with income, both numeric and non-numeric measured responses. So if you want to, I was talking about a name. You can see where the name is. Here you type the name of the variable you want to key in. Maybe it is age, maybe it is educational qualification, maybe it is income level, you say income or salary, whatever the name, you type the name here. And the condition is the name can be as long as 256 characters. However, there should be no space in between the name. So for example, if I want to key in a name of a variable, so let's say I want to say age of respondents. So I can type age. And when I need to explain more about the label, I can now type the full respondent age. And if I want to put it here under this name as age of respondent, I don't need to put a space. I can put other characters like dash or like underscore. So for example, for this particular one, I can type age underscore of underscore respondents. So SPSS take everything I've typed as a single word, age of respondents. But in order to make it as brief as possible, I can just put age. And SPSS will still take it as age, because it gives me a room where I can give the label as age of respondent or respondent's age. We are defining data now. Now, for this particular age, what type of data is we have to define the type? Is it numeric? Is it string? So we can open this. So you see numeric, you see comma, you see dot, you see scientific notation, you see date. Is it date I want to, especially if I want to put in date of birth, I can put in date format, dollar if it is money issue. If it is money I want to enter, I can put dollar. Cost, or if I want to give a custom currency, which is not dollar but ringgit or any other currency, or string. String means anything you put on string, you define as string, will not be used for calculation. You are not going to manipulate the number. So for age, age is number, because it can be 3, it can be 4, it can be 20, it can be 30. So we can say numeric. But if it is like, if it is, okay, we will look at another example that is not numeric later. So you can say numeric. Yes, when you get numeric, the SPSS will ask you width. How wide is the width of what you are describing? You can say 8 or 12. Once you have selected numeric here, you click OK so that this one will go. Then here, you can give as much as 15, let's say 15 as width. Do you have decimal places? Does age have decimal places? We also say you are 24 years old or 23 years old. So no decimal places. Decimal places is 0. We are defining the characteristics of this data age, so that when we begin to put in the age, the SPSS understand what we are putting in. Then here is the label. This is where you can type the full name or the interpretation of whatever name you have given. So I can now say respondent's age. Respondent's age. Here I can give space. It will take it. because it's label. Values. Here, since it is numeric, I don't need to put values. Since it is numeric, but if it is an ordinary data, where data were ranked or categorical data, I can describe value. We will use another example to describe value here. For now, the value is not necessary because it is a continuous data. Missing data, we don't know whether we are going to have a missing data, but if we want to have a missing data, in order to be safe, in SPSS, if there's a missing data, most of the time you define the missing data, or there's a way you tell the SPSS to look at the missing data. Then the column, how many columns now? 1, 2, 3, 4. Let's just put it at 8 that was there. Column there before was 8. Because we have nothing to do with column. Alignment, right or left, depending on where the alignment should be. Here, alignment is right, it's okay here. Measure. The measurement, what it means is that, is it a scale? It is ordinal, it is nominal. When it is scale, it is a continuous data. Something like age is continuous. We can take scale because age can start from 0 and go on to 1 million. If there's any age like that, 1 million days, 1 million minutes. So it's a continuous data. So now, if we have done this, we have defined the characteristics of age, so that by the time we started putting age on our data, the define our data structures and characteristics. Let's use gender. You know, gender is A or B. So for gender, it is numeric because we are going to type either 1 or 2, right? Because it's either male or female. So because age is male or female, we may decide to, let's decide to give it a string. But if we put it a string, SPSS will not use it to calculate. But if we want you to calculate the gender, there's nothing we need to calculate the gender anyway. So let's try and select string because it is either male or female. Now, width, we can give 15 so that SPSS will be able to write the name fully. Let's go to 15 or 12, male, female. 12 is okay. Decimal point, no decimal. What is the label for this? The label for this can be respondent gender or gender. You can still put gender. Everybody understand what is gender. Now here we want to put values because when you are entering in SPSS, you either use everything is coming in quantitative. We can say 1 standing for male. The label is male, 1 for male. Then you add 2 for female. Then we add. If there are more categories of gender, we define them 3, 4, as many as possible. But here we have 2, male or female. Then with this, we okay it. Okay. So the definition has been taken. So if you want it to be to the right or to the left, because we have said this is a string, that is why it is putting it on the left. If we change this string to numeric, it will give us alignment to the right. So it will give us alignment to the right. For gender, either they must be, since we have taken changes to numeric, no problem. Then let's, here, you can see under the measure, SPSS has shown it as nominal because we have given it two definitions, either one or the other. These are categorical values, one or the other, male or female. They are nominal in the sense that no one is greater than the other. So SPSS has chosen for us a nominal scale. Then let's try number 3 to be race. How do we, okay, on race or nationality or what's, okay, race. So race, let's go numeric, 8, yes, I don't know, let's say 12, so that it will contain it. After this, I will show you the data view, how it will appear on the data view. Then we have maybe nationality or race. How do we define our race? Can we turn it to nationality? Yeah. Okay, race. Yeah. So when we want to define race, there are various categories of defining race. We can say 1, let's say 1, Asian. 2, Black Africa. We can say 2 to be Black Africa. We had no decimal. We can say 3 to be Middle East. Had, we can say 4 is Western, the Western world. 4, yes. Had, any other, let me see any other race I can put. 5, Pacific. This is hypothetical. Pacific. So we can go on and say, okay, had, okay, no decimal, so that there won't be decimal point behind it. Okay, so now, when we call to measure, we can, it can still be nominal because none is greater than the other. None is greater than the other, either Asian or Black America or Black Africa or whatever. Now, so let's look at data view. When you look at the data view, you can see this has given us age, gender, race, and that is how all these variables will be labeled as according to our definition. So if you go for maybe this one, if you change it to income, we go to data variable view, we change the name to income.
Doctor.
Yeah.
What is the difference between the scale and the ordinal in the measure column?
The scale is a continuous 1, 2, 3, 4, just like money. Okay. For nominal is when you have, when we started about data types, variable types, we say there's nominal, there's ordinal. So nominal in this is the one that you only differentiate between two variables. None is greater than the other. So your categorization, either 1 or 2, is just nominal to differentiate. Okay. So the same thing when I use the Asia, about race or tribe or nationality, we are not saying one nation is better than the other, but we just differentiate them so that we know where each respondent come from. So it's a nominal data. For ordinal data is when you have differentiate between items, but one is preferred to the other. For example, level of agreement. Strongly agree, agree, not agree, strongly disagree. You will know between these scales, one is greater than the other. So if you have chosen, okay, let me put a data here to represent an ordinal data so that maybe it will make it clear. Let's look at satisfaction. Let's say this item number 4 is satisfaction. We want to measure how satisfied people are on online teaching. Let's put it that way. So because, and we can go on, we will now measure the level of satisfaction. Level online, this is now the label, online teaching satisfaction. That is what we want to measure, or that's what we have measured, online teaching satisfaction. So the width can be as more so that it will take online satisfaction as a rating. So now let's create value. So what is the level of your satisfaction? We can say 1, not satisfied. Not satisfied. That is for some class of people. 2, somehow satisfied. Somehow satisfied. You can see the level of satisfaction differs. One is better than the other. 3, the label should be moderately satisfied. Then let's say 4, satisfied. And let's say 5. And let's say 5, highly satisfied. Now, for this kind of categories, you know one is greater than the other. The only thing is that the difference between one another is not equal. They are not equally distanced, but one is preferred to the other. So when you say, okay, the SPSS knows when you are filling your data, when you type 1, the SPSS will take it as not satisfied. That is just the meaning. You have defined it here now. Now, when we get to the measure, because this one are graded, one better than the other, only that their distance are not equal, they are ordinal. So when you rank like that, that is ordinal ranking. So I think if we go back to our slides when we started, when we talk about variables and measurement of variables, ordinal, nominal, and scale or continuous, interval continuous were mentioned. So scale represents interval and continuous data, while nominal and ordinal are ranked data, depending on what the researcher has in mind. Now, back at this data view. So when you remember, we have said age is is continuous. Anybody, you can fill any age. SPSS understand. If you say 23, that means the first respondent is 23 years old, and you can fill the age respondent by respondent as you are facing them. Then when it comes to gender, of what gender is the person, male or female? Remember, we have defined 1 standing for male, 2 standing for female. So when you type 1, SPSS knows that this person is a male. And if you type 2, it knows that the person is a female. Then when you talk about race, remember we have categorized the race. If you type 2, remember type stands for Black African. So the person is a Black African. Then when you want to measure the level of satisfaction, maybe you type 3. Let's say 3. Remember, our 3 is moderately satisfied. So with this, we can fill these respondents, the responses from people, having defined what each one of them. So most of the time when you see SPSS, you see 1, 1, 1, 1, 2, 3, 3, 3 when they're in data field. All those 1, 2, 1, 3, 1, 4, they have their meaning, which has been defined under variable view. So the way you define under variable view is what you key in when you are filling up the data. So we have tried to demonstrate everything that we need to do at in data entry or data capture. So the rest of the name can contain letters. Variable name should not end with a period. So when you are doing variable name, it will not end with a period. This is variable name. As we have defined the data, these are variable names. So when you are defining them on the variable view, there should be no full stop, no period when you are defining the name. That's what it means. So then, okay, these are default names on the SPSS. We are changing variable 1, variable 2, variable 3 until 1,000 variable. But we can now change it, and that's what we have done by changing to sex, income, weight, height. The variable type determines how cases are entered. Yes, if the variable is, for example, if it is height, weight, or income, you but in case of sex, which we have done as gender, in case of this one, we can only define, we will need to define what sex we are talking about, whether it is male, female, or transgender. The variable types determines how cases are entered. So this is what we have just demonstrated. You can look at this at the other time to know how it is done, but at least this is what I've just demonstrated live for you now. So now on the data type, for the question you have just asked, ordinal data are Likert scale is a type of ordinal data that is used in research to give weighted scale. So for example, when you have very satisfied, neutral, non-satisfied, very dissatisfied, or excellent, good, average, fair, bad, you can see that this rating, one is better than the other, they are weighted, but the only thing is that the difference between fair and average, and the difference between average and good, they are not equal. So they don't have equidistance, but the one is preferred to the other. When we talk about categorical, it is dichotomy. 2 responses, yes or no, true or false, male or female, short or tall, fat or slim. So if you are using such responses, then it could be dichotomous and they will be regarded as nominal categorical data. So then about race too. When you use race, when no one is greater than the other, local, international Africa, international Europe, international Asia, international America. So all this one can be inputted, and that is how you define you define them in SPSS, so that SPSS will know that this respondent who is responding to I'm taking the data is from Africa, or is from Asia, or is from Europe. Is that clear now?
Clear.
Thank you. So this is an I think this is an exercise. Unfortunately, you don't have SPSS, but we can translate this to what we have just entered now. So if you want to do that, I've defined for you how to define the data. So let's go to our SPSS and see whether we can fill the, okay, do we add, is that height or weight? Let me check so that we had a column for the height or weight. Height, okay. So let's put height as our fifth variable here. Height. Height is numeric. Height, I think yes, 8 is okay. Then height. That's height of respondents. So since it's numeric, no, it's a continuous data. Missing value not, yes. This one, none. So the height, we can say it's a scale, because we are going to give height in their real height. So let's now go to data variable, because when you define in variable view like this, you key in your data in the data variable. This is data variable. Okay? So let's start. Give me the age of people in your class, about 10 people. Oh yeah. Number 1 is 23 years old. Number 2, oh yeah.
20,
20.
21, 22.
Okay, 21, 22. Do we have 25? Yes. Okay, 25. I had 25.
27.
27.
33.
33.
18.
18. Somebody say 33. Yes, what age again?
35.
25, okay. So let's try and put the agenda. So how many females do we have?
2.
Okay, 1, 2. Okay, 2.
2.
Okay.
1.
Okay.
2.
Yeah.
1.
Yes. Yes.
2. 1.
Yes.
2.
1. No, 1. If I put 2, there will be 50-50.
Wait,
Am I right?
Already got in the 5th row.
1, 2, 3, 4, 5, 6. How many of them? Okay, if I put 2, they will be 50-50. So I don't want it to be 50-50. Okay?
Okay.
Aha. So let one be greater than the other. So now let's look at race. 1, 1. That means 1, 1, 1. You remember is Asia, right? 2 is Black Africa. So do we have 3, 4, 1, 1? 1. Let's just believe the Asians are more in the class. So so level of satisfaction with online teaching. Let's go. Remember, we have graded between 1 and 5. So let's look at number 1 says moderately. So what is your opinion for the rest?
Very satisfied.
5. Okay.
Yeah, 5.
Any other one?
4.
Okay.
5 also.
Okay.
3.
3. Okay.
3.
3. Okay.
2.
Okay. 2. Okay. Now, can we put age, something like height? Oh yeah, tell me is it in meter or feet? Let's do in meter. 1 point something, 1 point, okay.
1.7.
1.5.
1.7. I am 1.65. Okay. What height again? 1.4? 0.5? Somebody said 1.7, right? Okay, I've taken 1.7. Somebody else.
1.8.
1.8. What?
1.75.
Okay, 1.75.
1.64.
1.64. Just hypothetical, yes. 1.3. What else?
1.22.
1.22. Yeah, this is a meter. 1.48 or 46. Okay. Now, you can see we have entered different data now. So this is how to enter data in SPSS. You define the variables, then you begin to enter them. So this is why they said survey responses are quantitative, because you change them to figures. Whatever response you get from the feed, you are changing it to figures through coding. Coding is giving them ascribed figures to make sure satisfaction level is measured. I think briefly understand data entry now. So do we understand how to enter data now into SPSS?
Yes.
Good. So yeah, saving the files, or if you, for example, if you have data that has been saved in Excel, you can export such a data. So when you get to SPSS, you can open, file, open data. When you open data, if you want to import, if the data is not in your folder under SPSS, but you want to get it from another format, you can open this place and choose Excel. So when you choose Excel, you can use for the Excel data and call the data. It will come up in form of this data view. But there is something to be done, especially if you need to code. You can now go back to the variable view and define each variable. But if there's no need to define variable, you want to use it as it is in Excel, that will be no problem. So there's possibility of importing from Excel into SPSS. Then after having done that, you can now begin to do some analysis on SPSS, like finding the descriptive, the frequency distribution, compare means, do some tests. So for example, from our SPSS here, if you want to do any analysis, the first thing is to go to analyze. Can you see where I put my cursor? Analyze. Is it visible to you?
Yes, Doctor.
Okay. So you click on Analyze. So it gives you a dialog box. This is where you choose what you want to do. If you want to report, it will tell you which kind of report. If you want to descriptive statistics, whether you want frequency or descriptives, you choose. We will come there. If you, for example, if you want to compare means, supposing you have a lot of data, you want to do all the t-tests I mentioned, you can see compare means. You can select here one sample t-test, if it is independent, if it is paired sample, or if it is ANOVA. So this is how easy it is in SPSS. You just select and set your parameters. Then if it is, if you want to do a linear model, you select linear model. If you want to see repeated measures, it's there. Then correlation, correlate. You choose correlate. For example, if you want to correlate, what do we correlate here? Do we say age and height? Does age has anything to do with the height? You know, then when you are growing up, when you are age 4, this is a particular height. If you are age 20, this is a particular height. So if you want to know within the distribution of the student in the class, we can correlate age and height. All we need to do is to select, go to correlate by variate, then you select your variables. So if you want to do regression, you go to regression. Linear regression, choose linear regression. Select dependent variable, select independent variable, and the regression will be done. And so like that. When it comes to scale, we are talking, for example, when you are in research, we are talking about reliability analysis. To know whether your instrument is reliable or not, we can do scale reliability analysis. So this will give us whether this questionnaire will give us adequate information. Non-parametric tests, we can go, just like we did for compare means, we can do this for non-parametric. I mentioned parametric and non-parametric. Non-parametric are for variables that are ranked, like level of satisfaction. So if you have rank level of satisfaction, I want to know the test. You want to do the sample, say one sample test or independent sample test. Because it is a non-parametric test, you choose non-parametric test. Then when we get to multiple imputation, complex samples, anything we want to do as we grow on in the use of SPSS, you will see it under analyze. Now, let's see if we can go for frequency. For example, we go for frequency. So in frequency, we can do frequency distribution, and we can find the mean, we can find the standard deviation and everything. What you do here, on this dialog box, you see variables. This is calling for which variables do you want to check their descriptive statistics. We can select all the variables and transport them into this variable space. So when we have done that, display frequency tables. Yes, the frequency tables will be displayed. Then we can even do more. Go to statistics. We click on statistics. What statistics do we want to know? We can select mean, median, mode, whichever one we want. We can select what is the minimum, what is the maximum, standard deviation. If you want variance, if you want range, you select as many as you want. Then there's something we call skewness and kurtosis. That is when you are checking the normality distribution of the data. And if you want to do that, we can select all. So if you select all this, all you say is continue. And when you have said continue, you have set parameters, you now click OK. So this is the result. So for statistics, for frequency, the counting will be there. So you can see it has counted. Everything is 10, 10, 10, 10, 10, number of 10. So then it will give you the mean, the standard deviation, the variance, skewness, then kurtosis. Everything we have selected, the range, the minimum, and the maximum. So for the age, the range is between 18 and 33. For gender, the range is between 1 and 2. For race, the range is between 1 and 4, which is 3. And for online teaching, minimum is 2, maximum is 5. So SPSS will just give you at a glance, and you can see everything at a glance. Then the frequency table. For gender, how many are male, how many are female? So for race, how many are Asian, how many are Black African, Middle East, Western. So you can see the frequency, we count one by one. If we have selected that the frequency should be represented in either bar chart or pie chart, it will also give us the bar chart, the pie chart. So look at the outline here. It's giving us frequency tables. And what are there in the frequency tables? We can get the title, we can get the respondents, the gender, the race, the online teaching, and height. These are the frequencies of what we have looked for. So we can cross-check, and it has given us which one, how many valid percent. For example, if there's a missing value, it will be reflected here that a particular value was not entered. So one can go back to check the table to check which one is having a missing value. Maybe as an error, when we are keying in our data, we just omitted to put the value there, or mistakenly the value there was deleted. So we can go back and check which one is the missing value there, and then we'll be able to check and put back the value. However, there are some responses that those who are filling your questionnaire will not attempt to. So this one can constitute a missing value. And there is a way of treating missing value. It's either you tell the SPSS to compute the average of responses on that line and put it in the missing value, or you define missing value, maybe by a particular number of figures. So this is a way of doing analysis. If we want to correlate, I say we should correlate age with height so that we know what is the relationship between the age. We can select correlate by variate, mostly by variate. What do we want to correlate? We want to correlate the height and the age. So we put age into the variable chart, then we put the height also. So we want to correlate the two together. Age is continuous, height is continuous. So we can do the same correlation. If any of them is not continuous, we will have to select the Spearman. So then the options, any other options, means and standard deviation, we don't need means and standard deviation again. Okay, continue. Then we flag significance at, okay. So we can now say, okay. So this one will give us a correlation table. And this is where you can see correlations. Then let's look at the correlations. What does the correlation give us? Is there okay, as at the table, the correlation is negative 0.11, negative 0.11, and it is not significant. Because if it is significant, it will be flagged. There will be double star on that line. So what does this one tell us? It tells us there is a negative relationship between the age. As the age increases, the height decreases. This is what the data we have entered shows. As the age increases, or as the height increases, so as the age increases, the height reduce. That is what the data, and let's check the data if that is correct. Now let's look at our data. When it is 23, 1.7, 20, 1.65, 21, 1.40, 22, 1.50, 25, 1.8, 27, 1.75, 23, 1.64. You can see this one didn't give a particular pattern of age increases, height increasing. So that is the how to check correlation in SPSS. Correlate, then select the variables, and you can see. So this is how analysis are done in SPSS. Let's go. Then I've shown you an example of a descriptive statistics now, where the frequency distribution has been displayed. And so also if you want to select mean, you go to descriptives and select mean, median, mode. If you want all of them to be selected, it can be selected. And you can see the dialog box here that shows mean, median, mode. You just check them. Once you check, you will see mean, median, mode. And again, let's look at our SPSS again. Analyze. You go to descriptive statistics, frequency, then you go to statistics. You see mean, median, mode. You can click median and mode. So everything will come out when you say OK. So here, the mean, median, mode has come up. What is the mean? What is the median age? And what is the mode? So you can see everything fall within 23, 23.7, 23.0, 23. So these are the ways of finding the mode, mean, and median in SPSS. It will just, with the SPSS will work it and bring the table for us to pick our results. So also, if you want the standard deviation, the same process, you select, just as the other one, I selected range, variance, standard deviation, and we can see it in our output. In the output, we see range, minimum, maximum, standard deviation, and variance. Everything has been selected, and it comes in a table. What else? Interquarter range, you can do the same thing. Then building charts. If you want to build charts, there is a menu that has to do that in SPSS, depending on the chart you want to build. So you go to graphs, and this will give you chart builder. So when you go to graphs and you go to chart builder, then we can now define the kind of chart. You can select the type of chart you have here and which of the variables you want to build chart for. So you select the variables, then you build the type of chart you want. Can I use this? Let's select this, put it here. So if this is the chart I want, and I select, let's make this 3 variables. So I can say close here, options, any other option, exclude. We define parameters. I think this is okay. Gallery, group, no, basic elements, any other thing. Yes, what will be on the y-axis and what will be on the x-axis. We defined the y-axis, the x-axis from our variable. If you want to, let's see if I can put age on one axis, age on one axis. A scale variable cannot be, okay, a scale variable cannot be. Okay, raise. Then what will be, okay, raise. What can be on this age? Can I put age or height? Let's try height. Okay. Then build charts. There must be something. Okay. Okay, is it a bar line now? That's a bar. Fine. So from here we choose anyone. I've chosen a bar line. Element properties. What are the properties of the element? Mean, bar exit, bar chart, bar 1. Display error bars, no. Bar. Okay. There must be something to apply. Maybe mode. Apply. So then any other options you have to take from wrap panel, description, default template, none. Include. System missing values are always excluded. Okay, exclude. Summary statistics in case, exclude likewise. If a template was specified by SPSS available on the edit menu, it is then the checked templates are applied in order with they are listed below. Okay. No option listed. Description, select a template, view its description. I've selected the template, but it's not showing. Okay. So something is I've selected something here, bar chart. So it should go. So what do reset? Okay. Select line, bar chart, basic element top. Oh, this. Gallery, where's the gallery? Okay. Yes. We have selected a bar. Height. Okay. This is what we use. Race. Height. Yes. Basic elements, group point. Where's group point ID? Clustering variable, rows and panel. Tiles, footnotes. Let me see. No. Options. Okay. Something is cluster in x-axis. No. Yes. So I think something is wrong here. When you build like this, this okay is supposed to highlight. So that's what I'm looking for. Why it's not highlighting? I'll check. But this is the chart builder thing in SPSS. And this will build a variety of charts rather than histogram or whatever frequency distribution. So we'll look at it, what happened whether the system, the software is complete or not, because it's a crack fashion. But that's the build, that's the graph, what build graph for different type of charts that we may have to build. But just for frequency, you can go to frequency and you get histogram, like frequency charts. You can do bar charts, frequency distribution percentages. Okay, frequency. Okay. Yeah. So if we have just used frequency to do the bar chart, this is what it will look like. But if you use chart builder, you can select different type of charts. That's just the difference between this frequency and the one chosen by builder. So we can demonstrate better when we look. Okay, select chart, select variable of interest. Okay, click on graph chart builder, select choice chart, then click OK. Aha. So that's the procedure. Find the mean. We now know how to find the mean median, so we don't need to follow this exercise again. At least I've demonstrated how to find mean on SPSS now. Then statistical test. There are different tests, and I think I've shown how to go on doing tests. We have dependent and independent variables. And if you want to test for relationship, just as correlation we did now, differences in motivation between, so there are different hypotheses. These are typical hypotheses that can create a relationship. For example, when you say relationship between gender and weight, just as we did between age and weight now, that means dependent variable will be defined, independent variable will be defined. For every relationship, we define the dependent variable and independent variable so that we know which one and which one are we testing against other. So these are hypothetical statements that can be tested. So just to, then there's what we call normal distribution. You know, we said if data are normally distributed, they are parametric data. If they are not normally distributed, then they are called non-parametric data. And this will determine the type of test you can do. Either they are parametric tests or non-parametric tests. So for normal distribution, you know, this graph may not be explainable, but let me use this one to explain the normal distribution. When you talk about normal distribution, we agree that the center, this is the mean. Then the data were distributed around the mean. If they have a kind of equal distribution to the left and to the right of the mean, we say they are normally distributed. And there are various tests like kurtosis and skewness can be used to determine the distribution of data sets, whether normal or non-normal. If they are not normally distributed, that means the distribution will be more to one side of the mean or the other. If the distributions skew to the right, to the positive side of the mean, we say it is positively skewed. And when it is to the left of the mean, it is negatively skewed. So these two, negative and positively skewed, are non-normal distributions because they didn't fall within normal, they were not equally spread around the mean. So there are different names. If the spread is like this, so which is not like a normal curve that we have seen, there are different names given to them: mesocotic, leptocotic, or pleocotic. These are just for statisticians. So different tests for how distributed data is either normal distribution or non-normal distribution. For normal distribution, you can get this test. So then we go to inferential statistics in where we are going to do some tests like hypothesis testing, correlation, analysis of variance. So because this is what inferential statistics is all about. So far, we have looked at SPSS and what we can do under normal descriptive statistics using SPSS. Any question? Okay, I think there's a message. Let me read the message there. Is there any message? Okay, no message. Any questions so far? Use of SPSS.
So far, so good.
Okay, so it is just a way of appropriately coding and entering data. When data is well defined correctly, then the SPSS does the remaining. So the problem is on how do we code. So for example, if you have race, just as we have described now, we should remember that when we are keying the data, whatever we ascribe for different responses is what is keyed in when you are doing it. So there won't be error in our keying in of our data. So let's look at some other tests or analysis we can do under inferential statistics. One, we say test of hypothesis. Here, this is where the issue of significance or no significance matters. So an hypothesis is a projected statement. It's just a statement of a relationship between two variables. Either we said age does not affect the height of people. So that means we are looking at the age and the height. Height depending on the age. Normally when we are growing up at different age, we have different height until we get to the peak of our growth that we cannot go taller than, because there's a limit to which a woman being can go to in height. When it is more than that, that is what we regard those people as extra tall, to be giants, because they are taller and perhaps huge, so huge, above the maximum expected, then they are called giants because they are big, they are tall. But there is an expected length. That's what people call 6 feet. Now the woman normal height is about 6 feet. So when you are going beyond 6 feet, it's becoming extra, that you are tall, but more taller than what is expected. So we can look at the relationship between the height and the age. So if we want to do that, that means we are going to take age at different age, what is the height? Not age of different people and their height. At different age of each individual, what is the height? So when you are 5 years, 10 years, 15 years, 20 years, 30 years, until the end. So what is the age? And when you look at that distribution, we may discover that at a particular point in time, we stop growing tall and we begin to be fatter and fatter. So one can put an hypothesis that age has nothing to do with height, has nothing to do with age, and it can be subjected to test. So when we try to make an hypothesis statement, for example, I stated 2 here, television time does not affect student performance in examinations. That means no matter the number of times a student spent in watching televisions does not affect his performance in examination. Or it can be the other way around, students perform better in examination when the television time is reduced. What this one is saying is that when you watch television less, you perform better. This is a statement, but there are other conditions that can make this statement hold. For example, if you reduce the time you are watching television and you did not read your books, does that translate to better performance? So when there is a relationship between watch time and performance, if it doesn't give us what we want, we now know that there is another factor influencing that relationship. Example 2 here says the soil type has no influence on size of cassava yield. Yeah, bear with me, you know, we are used to cassava plantation in Africa. So the soil type is expected to determine the yield. So soil type has no influence in the size of cassava yield. Then the alternative hypothesis will be the soil type affects cassava yield. So we can put it into test by using taking different soil type and taking the yield of cassava plantations. So it can be measured, it can be taken. And when we go through that, we can test the hypothesis either by correlation to look at the correlation between the two of them, if they actually have influences or not. And I can take just a survey of farmers and ask them. So whatever their responses is, I can put it into my analysis. Then for the hypothesis 1, I can take time to ask students, how many hours do you watch television in a day? They give me their hours, then I look at their exam performance. So that one too can be related to each other to know whether the time spent on television affects, how does it affect examination scores. So these are ways we can create an hypothesis. We create a statement of relationship between two variables and test it whether it is true or false. So when we are testing hypothesis, in SPSS we have what we regard to as p-value, which is a test of a significant level. So if our p-value is less than 5%, which is less than 0.05, then the relationship is significant. If it is greater than 0.05, it is non-significant. And that can determine whether we are going to accept our hypothesis or you are going to reject. For the simple correlation we just did now, let's check where the correlation is so that I tell you what is p-value. I think we did correlation now. Yes. Okay. Correlation. Let me check from the, okay. I can check from here. Okay. Correlation. This table, this correlation table, when you look at it, the coefficient of relationship is this one minus 0.111. The p value, the significant values, look at significant two-tailed. The value is 0.760, which is far greater than 0.05. And that is why I quickly said that it is not a significant relationship. So because of this insignificant level, we can reject a statement that age is determined, height is determined by age. That means height is not determined by age. Because it's not a significant, we can reject the hypothesis. So this is what we call the value below the correlation coefficient is what is called the p-value, the significant indicator. So if it is not significant, it will be greater than 0.05. And if it is significant, it will be less than 0.05. And the coefficient will be starred, either 1 star, 2 star, or 3 star, to show that it is a significant relationship. So any question about test of hypothesis?
No question.
Okay, so I go on. Let's quickly see what we can do within the next 10 minutes that we have. Because on Thursday, I want to see if I can put up a standard data so that we begin to manipulate, to do all this test, all this analysis. I think I will try and bring up a data on my own database. The one I have before, I call it, then we begin to do some of these tests, including regression, because we have not done regression, okay?
Doctor, how it will be tested for this lecture?
Just as I've explained, parametric test is relying on the assumption that the data we are using is normally distributed, and we can have parametric test. If it is non-parametric, the data are not normally distributed. And most of the time, statistically, when the data is not a parametric test, the mean in the case is taken as the median of the data set. So for correlation or relationship test, for parametric test, you use Pearson or point Becerra. All these are in the SPSS. You just choose either Pearson or point Becerra. For non-parametric tests, we use Spearman-Rowe or Kendall-B. So these are different correlation tests that we can do for whether the data is parametric or non-parametric. So, and these are other statistical tests. If you want to do one sample t-test, if it is parametric, one sample t-test. If it is not parametric, and the purpose for which a test can be done is put on this table, you can go over it. If you want to compare two independent samples, we can use this test, depending on whether the data set is parametric or non-parametric. Then we have discussed about correlation when it is positive, when it's strong, when it is weak. So in SPSS, these are the correlation, these are the assumptions. For example, if it is one variable, scale, if it is scale, we use Pearson. If it is not scale, we use rank order. So these are this is just a guide on what correlation we can do at a particular point in time. You will need this one when you are collecting data on your own outside. So, and this is the process for correlation. We have done that. At least I've demonstrated that. So if it is non-parametric, we use Spearman-Rowe, we select Spearman-Rowe. If it is parametric, we select Pearson correlation on rank data. So then the same thing if it is t-test, these are just notes on which are the process, what to do when you want to do the t-test. For example, test of variables we do now, when we get to one sample t-test, it will ask us to select the sample. This is gender of students and student weight here. When you select this, it will, then you can click OK, and it will give you the test. What we want to know is that whether it is significant or not, so that we know whether we are going to accept our hypothesis or we are going to reject the hypothesis. So these are t-test stages, different t-tests. I made this one comprehensive enough so that for your future references. So if there is a significant relationship, this is how to report. There was a significant difference between weight and height for male at PDs and for female at PDs. So this is how to report when we are reporting our test of significance. It's a typical way of reporting our test when we have done a pair sample test. So these are all t-tests, different t-tests, different procedures. An analysis of variance. When you get, for example, at our data, when If we go to analyze, compare means, where is compare means? We can see one way. So one sample t-test, independent test, pair sample, one way ANOVA. So just under the compare means, select whatever you want to do, and it will analyze it for you. Then that's the procedure. That could be the result. This is the typical result that will come out from one-way analysis ANOVA. So because we have done for ANOVA for one student height here, we can look at it. We look at the student height within the group. And within the group means between the male and female, using gender. So if you look at that, now you'll see which one is significant, whether there's a significant difference. In this analysis, there's a significant difference between the average weight of the male and average weight of the female. And that is why you see the F value, this is significant, the F value 0.023, and the significant value 0.882, greater than 0.05. That means both the weight of the male and the weight of the female, there is no significant difference between the two. So it is not significant. So these are just how to read the output of analysis. Then the same thing if we want to do chi-square, we go to analysis, descriptive statistics, and go to crosstab. Under crosstab, we select chi-square. Then we select the rows and column. So we will try and demonstrate this when we get to our enough data to do that. And when we do that, it will give us a chi-square difference. That is if we need chi-square to analyze. And this is used when we are talking about two categorical variables. If the two variables are categorical in the sense that they are maybe yes, either they are nominal or ordinal. So if the two are nominal ordinal, then we can do this. For example, level of satisfaction as well as gender. The two of them are categorical. One is nominal, one is ordinal. So we can use that under the crosstab to find the chi-square if there's a significant difference or not. So, and this is the procedure. Empowerment status, monthly income. Here we can put in the rows the gender, and in the column we put the height, or we put the satisfaction. And by the time we check the two of them, we check on chi-square, and it will give us a result. So when we get a result, we will know whether there's a difference between the two of them. Then we go to regression, which we will do with our data. So under regression, there's a dependent variable, there's independent variable. We select. SPSS, we tell you, we ask for dependent variable, and we ask for which one is independent. Once we select the two, we check parameters we want to see, and that will give us our result. So I think the data point I have here is not big, is too small. So that's why I said, but we can, which one can predict the other now? Let's see. Can the age predict the height? We have not done that under correlation. It was not significant. So I'm just trying to see how we can demonstrate regression here. Let's see, analyze. We go to regression. Where's regression? Regression. Yes, we go to linear regression. Which one will determine the order now? Height and age has been used. Let's see if we can try the race and satisfaction. Rate and satisfaction. Satisfaction is depending on race. Level of satisfaction, let's place this one as dependent, and let's put race as independent, just hypothetical. Then what are the statistics we want? Let's check statistics. What do we want? Estimation, model fit, yes, R square. We can need R square. We don't need descriptive. We may not need the correlation. Confidence interval, no. Dub Watson, do we need Dr. Watson? No. Continue. Let's see if R square will be given to us. So, yeah. So for this type of regression, we can see this is the model summary. Still not significant. You can see the significance of change. There's no significant change between race and level of satisfaction. So adjusted R square is 0.005. That means this is contributing 0.8 is contributing 0.5% to the level of satisfaction on online. So that means there's no relationship, strong relationship between the race and the level of satisfaction. So what it means is that race or the country of nationality does not affect the level of satisfaction of online teaching. So it is not a matter of race. That is what the model is telling us now. So let's look at beta, because I mentioned beta the other time. For standardized coefficients, beta, which is standardized coefficient, this is 0.071. So this is just 0.71. That is what is there. So insignificant relationship, because the model race 0.845 is far, far greater than 0.05. So this is what a typical regression output will give us. It will give us the model summary, analysis of variance, which is still not significant, and the coefficient. With the coefficient for race as a determinant of satisfaction of online teaching is insignificant. So age, and when we look at the R square tells us we are the contribution of race to level of satisfaction is 0.5%. So you can see it is so negligible. So this is a typical regression output, and these are the figures we'll be looking at when we do regression. I think the demonstration is make it a bit clearer for regression. We will use a more complex data on our tutorial class. So then this is all the table I just showed you now: model summary, ANOVA, variables entered, and coefficients. This is how it will be displayed as an output, and it's depending on how much we can read the output. Then these are, again, statistical test comparison. So we look at parametric, non-parametric, so that we can have this at the back of our mind whenever we want to do analysis on SPSS in the future. So these are the kind of tests we can do at different occasions. So any question for this runoff on how we can use SPSS? At least this is introduction to SPSS to you. Any question? We still have about 5 minutes. Please mark your attendance on Spectrum. So, any question?
So far, so good.
Okay, thank you. I will want us to We can go about, the slide has been uploaded on the PDF format. We can look at it so that you can use it as manual. If you have any SPSS, that you can just practice, look at what the screen look like and try to follow the examples to key in your data. So, and that will make, practice make perfect in SPSS. If we don't use it, we tend to forget some basic things. But normally, you should know that if you are outside there and you have data, especially a questionnaire survey data, SPSS is more perfect in analysis for such data and can help a great way. Instead of calculating by overhead manually, SPSS will run everything and it give you output which you can just report. So this is about 4 minutes more. Any other question? If there's no question, we can close the class today. Sign your attendance in Spectrum, and we'll see again on Thursday. I hope I will be able to put up, call one of my data. We use it to demonstrate what we can do in SPSS. Is that okay?
Okay.
So, okay, if there's no question, thank you for being in the class. Keep safe always.
Again, doctor, you said during Thursday, what should we do?
During, I said you can use the slide as a manual if you have opportunity of using SPSS to practice with. And I said next class, I will try and bring up a data that is already in SPSS format for us to demonstrate again all what we can do in SPSS, at least for this level. So is that okay? Did I answer your question?
Okay, we try to download SPSS.
If SPSS, I don't think SPSS is free, except you are going to be given a trial version. But if you come across anyone that has SPSS and you get it on your system, you can still use it as manual anytime, any day. So that when you get outside after graduation and you have to use SPSS, you will have an idea of how to go about it. Is that okay? Who is at the lobby?
Okay.
Okay. So then we can end the class if you are okay. This is all 1 o'clock. But don't forget to sign your